Reactive oxygen species, those little molecular firecrackers better known as ROS, may sound like the background extras in a sci-fi movie, but inside your bloodstream, they're the real antagonists of the aging story. These highly reactive molecules are generated as natural byproducts of oxygen metabolism, which is a fancy way of saying every time your cells try to breathe, they risk getting burned. In moderation, ROS have a useful side. They're involved in cell signaling, immune defense, and even orchestrating the cleanup of damaged cells. But when their numbers start rising uncontrollably, they go from cellular messengers to biological vandals, corrupting DNA, degrading proteins, and puncturing lipid membranes. It's a process often described as oxidative stress, and in the bloodstream, it's the fast lane to aging, inflammation, and disease. So where do these rogues come from? The primary source is your mitochondria, the energy factories of your cells. As mitochondria convert nutrients into ADP, a few electrons inevitably leak from the electron transport chain and react with oxygen, forming superoxide and other ROS. Under healthy conditions, your cells manage this with grace. But under stress, think poor diet, pollution, smoking, excess glucose, psychological stress, or even intense exercise without recovery, ROS production surges. Immune cells also produce ROS deliberately as a defense mechanism, like cellular pepper spray, but when that system stays stuck in attack mode, the damage becomes systemic. In the bloodstream, this becomes especially problematic. Your blood is the highway that connects every organ, every tissue. So when ROS levels rise there, their damage is not localized, it's distributed. They can oxidize LDL cholesterol, making it more likely to stick to artery walls and spark cardiovascular disease. They can damage endothelial cells lining your vessels, impairing their ability to produce nitric oxide, NO, which you need to keep blood pressure stable and vessels flexible. Over time, the blood itself becomes a source of tissue injury, rather than a neutral carrier. At the microscopic level, ROS attack lipids in the blood, lipid peroxidation, altering the structure of cell membranes and lipoproteins. They fragment proteins, leading to dysfunctional enzymes and misfolded structures that clog repair systems. They also slice through DNA strands, increasing the risk of mutations and telomere shortening. This is cellular aging on fast forward, an inner rusting that no moisturizer can fix. But don't panic just yet. Your body is not defenseless. It comes equipped with an elite squad of antioxidant molecules and enzymes designed to neutralize ROS before they cause irreversible damage. Leading the charge is glutathione, often called the master antioxidant. Made from 3 amino acids, glutamate, cysteine, and glycine, glutathione directly scavenges ROS and also recycles other antioxidants like vitamin C and E. It's like your cell's internal cleaning crew and recycling plant in one. Low glutathione levels have been linked to accelerated aging, cognitive decline, insulin resistance, and increased susceptibility to oxidative diseases. Then there's superoxide dismutase, SOD, catalase, and glutathione peroxidase, a trio of enzymes that break down specific ROS species into less reactive forms like water and oxygen. These enzymes operate in every tissue, but their presence in blood is particularly important for buffering against acute oxidative stress from a tough workout, a stressful meeting, or that third espresso on an empty stomach. More recently, indole metabolites have entered the antioxidant chat. As products of tryptophan metabolism via gut microbes, indoles like indole 3, propionic acid IPA, have been shown to reduce ROS and protect mitochondrial membranes. They also regulate the aryl hydrocarbon receptor, AHR, which influences genes involved in detoxification and oxidative balance. In effect, these microbial byproducts act like molecular negotiators, calming the chaos inside your cells and blood vessels. Other players include uric acid, which, despite its reputation for causing gout, acts as a potent antioxidant in plasma, bilirubin, and dietary antioxidants such as polyphenol and flavonoids. Together, these compounds help maintain redox homeostasis, keeping ROS levels low enough for useful signaling, but not so high that they torture tissues. Still, your antioxidant defenses are finite. Over time, as these systems get overwhelmed or depleted, damage accumulates. That's why ROS are central to almost every theory of aging, from the free radical theory to mitochondrial dysfunction. It's not the presence of ROS that's the problem, It's the imbalance between oxidation and the body's ability to recover. So, what can you do to tilt the scales back in your favor? Prioritize the basics: regular exercise in moderation, a diet rich in colorful plants, good sleep, and stress reduction. Foods high in sulfur, like garlic and broccoli, boost glutathione production. Fermented foods and prebiotics can increase beneficial indoles via your gut microbiota. Supplements like NAC, N-acetylcysteine, or alpha-lipoic acid may enhance your antioxidant capacity if used wisely. And interventions like cold exposure, fasting, and saunas may help stimulate your body's own defense systems through a process called hormesis, the concept that small stressors can train your body to get stronger. In short, ROS are not villains by nature. They're just volatile, and they demand respect. In a balanced system, they serve a purpose. In an unbalanced one, they age you from the inside out. So next time someone talks about anti-aging, remember, it's not just about creams or supplements. It's about managing the red-hot chemistry in your blood and letting your internal fire burn bright without burning out.